Okay, question B. A batik printer know that from the past experience when printing batik clothes, paint spot occur on the cloth random at the rate. So when you come to the term of rate, so this one is like average. Indicate that this is your lambda in Poisson. 3 for every 900 cm square. So the batik printer wishes to print a piece of the cloth with 35 cm times 30 cm. So this is the area for 900 cm square. Your lambda is 3. When you want to print 35 times 30 cm, how much the area? Okay, 1050. Then you have to find out what is your new lambda here. So do your ratio. 1050 times 3 over 900. So your new lambda here 3.5. Correct? So x will be the number of paint spot. So x distributed Poisson now is 3.5 for 1050 cm square. So this is from questions. Identify your x, identify your lambda, identify your distribution. Then we come with question number 1. Find the probability P. After painting the cloth will contain not more than 4. So the number of paint spot not more than 4. So it will be less than equal 4. So by referring to this distribution, we can find it from table. So to read it from table, we need the symbol of more than equal. So if you want less than equal 4, we will take 1 minus, we will take everything overall 1, then minus more than equal 5. You need less than 4, so we will start 5 onwards, minus off. So for the table, find out from your Poisson, read out. So in the page of 3.5 in the page of 12. So read out your reading of 5. Your page of 11. So 3.5 reading of 5, it will be 2746. Then we come to number 2. So 8 of these clothes are painted consecutively. Find the probability that 3 of them contain exactly 4 paint spots. So are you finding the paint spot? No, so we are not finding the paint spot. Now we are finding the groups. So your object here already changed. The distribution already changed. Situation changed. So what you want to maintain here is contain exactly 4 paint spots. So when you sample, so this 8 is indicate you now you have sampled 8 groups. You want to find from 3 of them. With the situation exactly 4 paint spots. So we will start with finding the probability for the situation where exactly 4 paint spot. So if it's still finding paint spot, means it will still under Poisson. X equals to 4. So Poisson 3.5. When you want to get reading of 4, we will start from 4 minus 5. Then you will get x equals to 4 alone. So reading of 4, 4, 6, 3, 4. Minus reading of 5, just now we read it already. So now we come to the new distribution where x will be no longer x. We don't use the symbol repeat. So we use another symbol. Y will be the number of clothes having exactly 4 paint spots. So y distributed binomial with the sample given here, 8. Situation of the probability getting exactly 4 paint spots, 0.188. And they ask us to find probability that 3 of them. So means exactly 3. Y equals to 3. So in binomial, with the probability 0.1888, we don't have that table. So only we can calculate by formula. So using formula, NCR, HC3, P power 3, Q power 8 minus 3. So what is your Q? 0.9112, 0.8112. So you will get 0.1324. Then we come for number 3. It is known that printer will reject a paint job if there are more than 4 paint spots on the cloth. So by using suitable approximation, find the probability out of 40 pieces. So the situation change again. Just now is example exactly 4 paint spots. Now 40 sample, more than 4 paint spots. So P difference, sample also difference. So start from beginning, we have to find out what is the situation more than 4 paint spots. Number 3, so paint spot is denoted by X, more than 4. So if you want more than 4 in table Poisson, more than 4, it will be reading equals to 5. So it will be 0.2746. So this is your P for the situation more than 4 paint spots. So sampling now is 40 and is 40. Okay, so change. So since y and x already used, I use another symbol to denote it. Let's say m is equals to the number of clothes having more than 4 paint spots. So m distributed binomial 40, 0.2746. Then what's the questions? 5. The probability out of this 40, you have more than 10. You want to find probability m more than 10. So this is a question. Okay, so look at the distribution and this question. Are we going to solve using binomial? No. Why? You have to see the condition of the binomial. The first one, n is large. When we say n is large, it doesn't mean that more than 50 is large. So the keyword is start from the condition number 2 when NP, what is that? 40 times 0.2746, the mean. What's your mean? 10.998. 948 or 98? 984. Already more than 5. So in your notes, your situation only saying n is large, but it doesn't define it what is large. Alright, but in your notes, they surely have this situation when NP more than 5 or NQ more than 5, you need to do distribution approximation. Alright, so this one already fulfilled. N is large 40. NP is more than that. Then situation number 3, probability is it in between 0.1 and 0.9? Yes. So all of these 3 conditions fulfilled means binomial distribution need to approximate to normal distribution. Where normal we need mean and variance. So means we have already, but variance we haven't. We find out the variance, which is NPQ. The Q will be so what's the variance? 7.97. Give more decimal because this one just beginning of the question. After that, later we need to minus something like this. 9. 7.96. 8 or 7. Lepas 7 ni apa? Tinggalkan out of 8. This one mean correct ah? Double check this mean correct or not? 40 times 2746 correct or not? Correct? Okay. So distribution normal, which is mean 10.984, 7968. Then we start back from the questions. They want us to find here probability n more than 10. So our working step, it will be this one, original start from binomial. Then we have the next procedure, change the question to normal. Then start using normal distribution to solve this. We need z-score. Then drawing, find out from table to get answer. So from binomial change to normal, what we need to do? From discrete change to continuous. From nombor bulat-bulat pergi nombor decimal. It will be CC, continuity correction, whether plus or minus 0.5. So when we do continuity correction for this, more than 10, 10 involved or not? 10 involved or not? Included or not? No. So means the decimal we can start from more than 10.5. If you take 9.5 means the value of 10 will be included. So it will not more accurate. Alright, so it will start from 10.5. Then now already become normal, continuous, under continuous random variable. To change to Z, it will be minus mean over standard deviation. In the distribution here is variance. So to get standard deviation, square root of 7.968. So the z-score, we round off to 2 decimal. Then we can read table. So what's your z-score? Negative 0.17. So that's why just now I asked you to get mean and variance more decimal, so that when we calculate to the z-score, we round it off to 2 decimal, it will not have rounding error. Alright, later rounding error, I do 17, you do 18, or another people do 16, reading will be different. So no more accurate. So get more decimal before you come to the final answer. So you will be going to get this region draw out negative 0.17. More than that means we will need to get this region. How to get this region? In the table, we only have tail. So 1 minus the left tail. The negative tail, we will read it as positive 0.17. So now we can read the table from the normal 0.17. 0.17 here, 4325. Five, 6, 7, 5, is it?